Hi everybody. I hope that at least someone in someone with us. Okay, yeah, please type something in the comments. Yeah, if you hear me well and you see the first slide. Oh well, yeah. Okay, let's wait for some minutes till everyone is joining. Okay, yeah, thank you for your comments. Yeah, so while we are waiting, please share your updates, how it's going with the tasks, how it's your mood for this evening, and yeah, how's your progress? Okay, 2 minutes has left. I guess that yeah, we can start and wait while others are joining. So our agenda for today is our acquaintance with the Helm. And introduction to the Helm. We will explore and dive deeper to the architecture, to the Helm charts, to the demo deployment, and to the basic Helm commands that will help you with that with that wonderful journey. Okay, we can get started. Yeah, let's start with the introduction. Yeah. So Helm is first of all, package manager for Kubernetes, similarly as NPM or Yarn. And by the way, it's not just a package manager, it's also a deployment management for Kubernetes. Instead of having to define various Kubernetes resources to deploy an application, with Helm, you can just type a few commands out in the terminal, type enter, and you're done. Also, Helm manages dependencies. So when a Kubernetes application depends on another service or application, Helm can automatically download and install all the dependency chart. So with the other package managers, charts are stored in specific Helm repositories. It could be local or public repositories, by the way, and it simplifies the distribution and sharing of Kubernetes application. So Helm can be connected with the repositories to download and upload charts. So in the chart directory, you can find the following structure. Yeah, the first and main file is a chart YAML, and this file contains metadata about the chart, like name, version, Kubernetes version, and also Helm version, which is required, and another information that describes the application. Charts folder is a directory which contains the charts that chart depends on. This folder contains the dependency, all the dependencies for this chart. And as well as template folder contains templates manifest for every Kubernetes resource that's required for application, like service, deployment, or config map. By the way, Helm uses Go template language for rendering resource templates under this directory and generate corresponding Kubernetes YAML manifest to be passed to Kubernetes. And the last part is values.yaml. This file contains dynamic values to be injected into the template to generate Kubernetes manifest. Helm uses values from this file as default values, but we can override it by using another file and passing it as a parameter with the Helm install command. Okay, So yeah, Helm has four basic concepts. The first one, as I mentioned before, is a chart, which is a collection of YAML file. It's a kind of bundle of the Kubernetes resources needed to build the Kubernetes application. For visualization, Helm charts can be compared with a Docker image. Yeah, as it mentioned on the slide, the second concept is a config, which is the configuration in the values YAML file, which contains configuration explicit to a release Kubernetes application. It can be the config for service, ingress, or deployment, or any other service. Until specific applications such as Kafka, Console, Vault, and others. Next one is release. Release is a chart instance is loaded into Kubernetes. It can be viewed as a version of the Kubernetes application running based on the chart and associated with specific config. Yep, and the last concept is repositories. Is a repositories of published charts. It could be private and available only within the company or public. It would be available through the Helm Hub. Some charts may have different versions of many companies or publishers, and particularly charts in a stable repository must always meet the criteria from the technical requirement of Helm. So why do we exactly need Helm? Because Helm offers several key features that can help you to overcome the challenges encountered when managing application deployments on Kubernetes. For better understanding the why behind using Helm, it's always important to recognize the Kubernetes challenges. So let's explore the features of the Helm and the corresponding challenges it aims to solve. The first one is a package management. This is a part we discussed previously. It enables automatic and consistent application installation on Kubernetes. By using Helm charts, we avoid manual process of deployment and managing each Kubernetes resource individually. Next one, templating, is is another reason for using, because when managing multiple Kubernetes environments, such as testing, staging, and production, we always need to deploy our resources with a variety of different specifications tailored to each environment. For example, we might deploy only one replica of a pod for testing, while deploying 3 replicas for staging and production. Instead, maintaining multiple YAML manifests for each object to accommodate different environments. Helm offers a way for templating the YAML. For example, when we create a YAML file for a deployment object and create separate values for each environment. So we can instruct Helm which values to use in a specific deployment, depending on the environment we are targeting. And next one is versioning and release management. So another challenges with Kubernetes is the deployment. It's the keeping track of the application versions installed on the cluster. It's always difficult to maintain the history of each object, and we always need to be able to easily upgrade or roll back a specific version or state of the application. So, for instance, Helm addresses this problem by introducing the concept of releases. And Helm itself, release, is simply a deployed instance of the Helm chart. And in other words, when we install the application on Kubernetes using Helm chart, we actually creating a release. Helm keeps track on the versions of each release. And for instance, after an application is installed in a cluster, Helm marks this release with a specific version. Yeah, and use any command, Helm applies the changes to the current release and it marks it with a newer version. for sure, we can roll back to a specific version using another Helm command, and Helm will apply required changes to bring each resources with release back to its previous state. Yeah, let's explore another topic and how Helm works under the hood. So, yeah, as you see on the picture, yeah, our main actor is a user. User is sending Helm commands, and after that, these commands are parsed with the two basic components of Helm executable. The first one is Helm client, and the second is a Helm library. Helm client is a CLI tool that users interact to manage in the Kubernetes cluster, and it's a primary way users install, configure, and manage Kubernetes resources using Helm charts. And Helm libraries refers to the ability to use Helm as a Go library in the other software projects, enabling developers to integrate Helm capabilities into their own applications. Yep, and the two components are creating and updating the resources while communicating with the Kubernetes API servers. Yeah, let's go to the more practical part and get in the Helm chart. Yeah, our first step in working with Helm charts is to obtain the chart itself. As we discussed, we can build our own chart from scratch, or we can get ready chart from one of the public repositories. Let's download the pre-made chart for simplicity. Yeah, as you can see on the picture, we are using command Helm repo. Yeah, we're adding the Bitnami repo, and yeah, we're ensuring if it was downloaded successfully. Here we used the Helm to pull command to download the Helm chart for WordPress for Bitnami repository. And as well, as you can see on the screen, it's important to note that chart folder contains other charts, which are dependencies for the main charts. Dependency management is one of the chief benefits of Helm because it simplifies how we control our chart dependency and automatically downloads them when needed. Let's check a part of the resources file on the templates repository, directory, and see what they looks like. So what it means. This is the templates and features of the Helm that we talked about. Helm, from his side, enables us to inject dynamic values into our templates to generate a resource manifest. These values are represented by the above format and are passed to template through values.yaml file. When referencing these values in our template, the Helm engine will start replacing each value with a corresponding name from the values.yaml. After all values are substituted, a final manifest will be generated and passed to Kubernetes to create the resource. So now let's install the Helm chart. Now, because we understand how things are working under the hood, let's install and check what will happen. First, Helm install will pass all the requirement charge file and values to the Helm engine for rendering. After that, we specify a release name in the command, which my release is followed by the pass our chart directory. Release is running instance of the chart. This is how Helm tracked the installed charts on the cluster and their version. We can use the same chart to install different releases for the same application. That's why using the release name beside the charts is useful. To verify which releases is currently installed, we can use the ls command. Now let's check the deployment from the Kubernetes perspective using kubectl commands. It could be kubectl get deploy. And so after that, you'll see that my release WordPress app is installed. So I guess, yeah, that's mostly it that I was expecting to tell you. I hope it was pretty informative for you, and especially while solving the existing task, you will have a better understanding how it's working, and you got useful information. So now it's time for questions and answers, and feel free to share all your thoughts, questions, concerns. I'm all yours. Thank you, Pavel, for joining. I see we have newcomers here. Hi, Ivan. Currently, we're already done with the main part, so feel free to ask any questions you want according to our today's topic and the related task. Probably you have any challenges while solving the task. Feel free to share. Our audience, it's not active today. Approximately, it's because of the time zone. It's pretty early, especially for the European time. I don't believe you don't have any questions. Okay, I guess that it was enough time for today's. Oh, sorry. Oh, yeah, absolutely said with you, Anatoly. Yeah, it's kind of fresh air after the fourth complicated one. Okay, I think that we had enough time for Q&A session. Anyway, this stream will be recorded and you can easily find that on YouTube. So feel free to check that once again. Yes. Also, I'm all ears in the Discord, and feel free to share. Uh, sorry, comments are added. Yeah, that's absolutely right because it's always tricky when you're working with the network and all the access rules, and it's not only related for the Kubernetes, it's also for each cloud and any service um, service issue. Okay, I guess we are done for today. So I'm waiting you at the Discord and have a good time wherever you are.